Today we're going to be talking about transformations. There are many different kinds of transformations. Today we'll be discussing translations, reflections, rotations, and dilations. Dilations are probably new. We have not gone over that before, so that will be an introduction. But let's start with this part of your notes. So we're going to skip over that top and go straight down to this part. Let me get a good color here. Yeah, that's good. Okay, so this very first one, you notice that your, first of all, your letters, notice what's different. This one has a little tick mark, and that we call prime. So this one's called A prime, where this one is just A. Now, there is an official name for that. Mathematicians call this very first one without a tick mark, this is our pre-image. So go ahead and label that in your notes. This other one is just your image or your new image. So the tick mark or the prime is your image, and the one without the prime is the pre-image. This is very important when we're discussing transformation so that you know what direction that transformation went. So it looks like this transformation is going to go backwards. Now, one rule about moving on a coordinate plane is that you can only go up and down and side to side, and you already know this. So you can make a vertical change or you can make a horizontal change. It looks like the pre-image either took this path, it went horizontal and then it went vertical, or it could have gone the opposite. It could have gone vertical first and then to the left to make this other shape. But you will notice that it's exactly the same, so they're congruent shapes. All of the different details in the face, the smile, the emoji is the exact same. So nothing's twisted around or flipped or rotated or got big or small. We call these kinds of transformations translations. Translations are just, whoa, what did I just write? Translations. And translations are just simple slides. Okay, so a translation is a slide. I want you to go ahead and circle the SL. This is going to help us remember that translations are slides. Okay, so just moving that figure down and over. The next one that we come to is a mirror image. You'll notice the eye on this one and the eye on this one. They're not in the same position in the two images. So everything seems to be size-wise congruent, but the placement of each of its details have flipped. We call this kind of transformation a reflection. And a reflection is just simply your pre-image has flipped over some line of reflection. So this is a flip or a mirror image. We're going to circle the FL in reflection to remind us that this is just simply a flip. All right, so we're going to look at our image names to figure out which one is the pre-image and which one's the image. So this one right here is the pre-image. So it looks like, it has flipped over the y-axis. So we have done a flip from quadrant 2 into quadrant 1. So this one right here is the image. And if you'll go ahead and label that in your notes. All right, the third kind of translation we're going to get into is a rotation. A rotation is simply a turn. So you're taking the exact same congruent figure, and really that's the image. You're taking the exact same congruent figure and you're turning it around an axis. For right now, we're going to be turning it around the origin. So it's going to make a 90-degree turn here. Each time it flips into a new quadrant, it's 90 degrees. And we'd be going clockwise. So we would call this a 90-degree clockwise turn. Okay, and we're going to just label this the image and the pre-image. Okay. The last one is called a dilation. And a dilation uses a scale factor to enlarge or reduce. So down here on keywords, I've got a little text box in my way, so just disregard. So we're either going to enlarge it or reduce it by a scale factor. Hopefully you have more room than me. Okay, so it looks like the image, the pre-image, is the bigger one, and it shrunk or reduced inside to create the new image. So there was a reduction in size. The way that you can tell that it's a dilation is it's a congruent figure in all of its detail, but its size has changed. So now instead of saying these two shapes are congruent, we would say that these two shapes are similar. They have equal angles and equal details, but one is smaller and one is larger. Okay, so let's get into some vocabulary. Up at the top, let's go back to it. To transform a shape or figure means to change it. You're transforming it. In general, we can change the size, location, and direction that a figure is facing. The shape or figure before the transformation is called the pre-image. So the one without the prime symbol. We might label it as A, and you'll notice it does not have the prime. The shape or figure after the transformation is called the image. And it would be labeled with an A prime. You'll notice that now it has that little tick mark. So these are the vocabulary we need to remember: pre-image, image, and transformation. So where would you see these types of transformations in the real world? Translations, I just saw one when I was going to San Diego, and it was on one of those conveyor belts. Now these are amazing if you are running late for your flight and you have to get all the way across the airport, and they run on the ground and they move. And so you just stand here and pretend like you are moving super fast because you're cool. And they take you to the other side. So it's just moving you across. You're the same person. You're not flipping up and down and rotating. You're just going straight across. So that's a real world translation. Reflections. If you think about the image of a landscape on a body of water. So let's say you have a lake house, and hopefully it's bigger than this, and it's right on the water. Well, on the water, you're going to see a reflection of the house, and it's going to be a perfect reflected image of that house. So that's a real world reflection. Rotations, well, a tire or a wheel of any sort. As it turns, it's making rotations. So that is another real world. So, or a Ferris wheel even would be a great real world rotation. Dilations, when you go to the eye doctor and they're testing your pupils, they're going to put some stuff in your eye. It's really kind of cool. And they're going to put that junk in your eye, and then all of a sudden, instead of a normal pupil, you have a large pupil. Same pupil, it's just enlarged. So still the same characteristics, but now your pupil's enlarged. They'll give you some cool glasses to wear on your way out. They're really not that cool. They're actually very embarrassing. So hopefully you will never have to do that in your life, but who knows. All right, let's go down to congruence and orientation. Congruence refers to whether or not a figure has the same size, trying to do two things at once, and shape after a transformation. So does it continue to keep its same size and its same shape? Then we would call it congruent. Congruent means equal in all ways. Orientation of the figure refers to whether or not the figure is facing the same direction on the coordinate plane. So orientation of the figure, which way is it facing? Orientation of the figure, which way is it facing? Orientation of the vertices refers to the order in which your vertices are labeled. So in other words, if you have triangle ABC, and you flipped it across, you had a reflection, and it became CBA, the order in which you would read those vertices has now changed. So we call this an orientation of vertices change. So looking at number 1, we notice, and I actually just did an example just like this. I noticed this is triangle ABC. It becomes, because of the prime, see the prime? It becomes CBA. Okay, so this transformation looks like is a flip. We call those types of transformations a reflection. Okay, the size stayed the same. The orientation of the figure, remember we're talking about which way is it facing. So if I were to draw a face on my triangle here on the pre-image, and then I flipped it and I looked at that same face on the image, the way it was facing has now flipped. So we're going to say that it changed. The orientation of the vertices, if I was reading this triangle from left to right, I'd say A, B, C. If I was reading the other triangle, for instance, I would say C prime, B prime, A, C, B, A. So now the order has changed, therefore the orientation of my vertices have changed. Okay, so just a couple vocabulary words to worry about in today's lesson, but nothing too big. I want you guys to finish the notes and check with a partner once you have filled out all of the pieces in each of these boxes to make sure that you are getting the right thing. If you get something different, then go to another person and both of you compare with them and see if all 3 of you can come to a conclusion. I can take any questions tomorrow in class. All right, have a wonderful rest of your night.